X being the smaller of the two numbers, we have managed to list down all the possible x's here. And we have calculated for the probability that x is equal to 2 by counting the number of 2's that appear out of these 36 possible outcomes for x. So 9 2's appear. So 9 out of 36 gives us 1/4, which was what the question wants us to show. The next thing that we want to do is to calculate for the expectation of x. And for the expectation of x, we have a formula. We discussed it last week. So for the expectation of x, we are going to be making use of this particular formula here. It is going to be the summation of x multiplied by the probability that x is equal to x. That is why we do have the motivation to try to construct for ourselves first the probability distribution, which is going to be in the form of a table. So we're going to try to fill up our probability distribution table. But before that, let's try to recall. What is this expectation? Expectation is the average. So shouldn't expectation be calculated in the same way as we have calculated average since our secondary school? Has average changed just because the name was changed from average to expectation? Let's try to look into this one more time. So if I were to come back to this question, how did we first calculate the average in our Sec 1, Sec 2? So we were calculating average. When we were calculating average, what we will do is I will try to add up all the possible outcomes, which means that we will do a 1 plus 1 plus 1, then all the way until 2, then 3, then 4, then 5, then 6. And I'm going to divide this entire thing by 36. That was how we calculated for average. And when I calculated average this way, yes, it was fine when it was when we were in our Sec 1, Sec 2, because the number of outcomes are actually very, very few, right? We are just trying to calculate maybe 5 possible outcome, 10 possible outcome. But when the outcomes started to grow, that was when we started to look at average again, I think in our Sec 3 and Sec 4. When outcomes start to grow, when the sample size starts to grow, one very realistic thing, if this were to be happening in our real life, right? One very realistic thing is that you're going to start to see repetition. So when we start to see repetition, maybe it is a good idea for us to consolidate the way that we have calculated rather than adding every single thing that is listed down here. Rather than adding every single thing, what if we were to add it based on the how often the number appears? That was when in Sec 1, in Sec 2, in Sec 3, Sec 4. That was when in Sec 3, Sec 4, we move on from average to, it was given a new word again, to mean. We move on from average to mean, although mean is still representing average, but we will make use of the frequency table. You remember? In Sec 3, Sec 4, we constructed for ourselves a frequency table. So X is all the possible outcome. F represents for me the frequency. So if I were to look at the frequency, how many times will 1 appear? If I were to count, 1 appears 11 times. 2, we have just counted, it appears 9 times. And 3, 1, 2, 3, 4, 5, 6, 7. 3 appears 7 times. 4 appears 5 times. 5 appears 3 times. And 6 appear 1 time. This is the frequency table, which will also allow us to calculate average or mean. So it is going to be 1 time of 11 plus 2 times of 9, because 2 appears 9 times in my list here, and 3 is going to be appearing 7 times, 4 appears 5 times, and 5 appears 3 times, 6 appear 1 time. And I'll divide this by all the possible outcome, which is 11 plus 9 plus 7 plus 5 plus 3 plus 1. Divide this by 36 possible outcome. So by shifting the way that we have calculated average from having to add up every single value that is here, now by consolidating same values together to come up with the frequency of that particular outcome appearing, now our calculation immediately has become more condensed. This is good. This is good because we are trying to deal with bigger and bigger set of data. So the frequency table works. But if you think about it, when I look at the frequency table, for example, 2 appears 9 times. Okay, 2 appears 9 times, but what does it imply about 2 with respect to the entire data set? It actually doesn't tell you that much unless you go and look at everything over again. So we know that frequency table, or making use of frequency to calculate the average or the mean, is a good idea because it makes calculation faster, but it still doesn't give us a good impression, a good idea of how the individual data is compared to the entire set of data. So what if we were to try to still continue to calculate average just like how we have done in Sec 1, Sec 2, then Sec 3, Sec 4, but we change our perspective by reorganizing this set of calculation one more time. And that is what we are trying to do now in H2 Math. We are changing the name of average from average to mean, and now we are calling it the expectation of X. Okay, it doesn't change. Regardless of whether we are adding every single thing together or we are adding based on this frequency or what I'm going to be doing next, the result is still going to be the same number. So it is still going to be the same average. But if I can just change my perspective rather than writing it this way, what if I were to just take this divided by this and writing it as 1 multiplied by 11 over 36. Then this divided by this, it is going to be 2 multiplied by 9 over 36. Then after that, 3 multiplied by 7 over 36. And all the way until the very last one is 6 multiplied by 1 over 36. And what is 11 over 36? What is 9 over 36? What is 7 over 36? 9 over 36, we have just talked about it. It is the probability that 2 is going to be appearing in or amongst all the outcome that we are looking at. Which means that we are shifting from looking at it from the perspective of frequency to now looking at it from the perspective of probability. And if I can just construct another row here, which represents the probability, and this is our probability distribution table. It is going to be 11 over 36. Here it will be 9 over 36. 3 will appear 7 out of 36 times. This will appear 5 out of 36 times. This is going to be 3 out of 36 times, and this is 1 out of 36 times. And if you just look back at this, x is equal to 2 again. 9 out of 36 times, it is 1/4. And this 1/4 is actually particularly meaningful. You know why? Because instead of just us talking about 2 appearing 9 times, now we are looking at 2 appearing 1/4 of the time. This is 36. This is us looking at 2, but at the same time, if I have access to its probability, then I know how often 2 is going to appear with respect to the entire set of data, and this is good. And that is why this gives us a good step towards a better analysis of a bigger data. This is statistics. And if I were to consolidate this again, in terms of notation, this is actually summing up all the x multiply by its corresponding probability. So it is going to be summing up all the x multiplied by the probability that x is equal to x. And this gives rise to our formula here, which was what we talked about. In the exam, you should definitely just simply apply this formula. It is not necessary for us to go through frequency, then after that, derive this, then get this. We should just use this. Since we will probably be asked for the probability distribution table, we should be able to get our expectation fast. Next, let's discuss about variance. What is variance? Variance is the